Alright, welcome back. This is the discussion video for 10.9, which is on systems of inequalities. There's a couple of questions we'll talk about, so let's just dive into it. We're going to start with numbers 7 and 8. So 7 and 8 have a system of inequalities. That system is y is less than 9 minus x squared, and y is greater than or equal to x plus 3. Okay. And we're asked to graph this. Okay. So the first thing that I want to do is find the borders of these. Right? And these borders happen on the equality. So instead of less than or greater than or equal to, I'm going to write these all as y equals 9 minus x squared and y equals x plus 3. Because that's where the border happens, whether it's included in the graph or it's not. It happens at the equal, right? And so we can also then determine whether it's dotted or a solid line based on what the original inequality is. So this border that happens at 9 minus x squared is going to be dotted because the original inequality is strict. It's strictly less than. And so maybe you just write a little dot over here, dotted line, right? But it's going to be a dotted line there. This other one at y is greater than or equal to x plus 3. The border happens at y equals x plus 3. That's going to be a solid because of the inclusive equation, right? So I want to find those borders first. So let's start and find the border of the first one. It's 9 minus x squared, and there's many ways of doing this. You can find some points. You can plug in x equals -1, 1, -2, 2, just a bunch of points. But note that if it's a negative x squared, that means it's just going to be a parabola that's been shifted upside down, and then the 9, rotated upside down, and the 9 is just going to shift it up by 9 units, right? So in the end, I'm going to have at 9 this parabola that just goes down. And that's my border. I should have made it dotted, right, because it's strictly inequality, so I'm going to make it a dotted. I can cheat a little bit because I'm on a whiteboard. There's my first one. Now, it's an inequality, so I am going to have a shaded area. It's either going to be inside this parabolic region or it's going to be outside of it. I have to figure out which one. So I'm going to test. I'm going to test, say the point 0, 0, because that's an easy one, into my first inequality. In fact, into the inequality. I don't want to do it with the border. So I'll plug 0, 0 into here and see if it's a true or false statement. So that gives me 0 is less than 9 minus 0 squared, or 0 is less than 9. This is true. Because it's true, that means I'm going to shade where 0, 0 is in this region. So it's inside this parabolic arc, and so my solutions to the first it's somewhere in this area here. Okay. I'm going to need get rid of a little bit of this little testing math right here. That's the first inequality. The second one is x plus 3. That's just a line. It's a straight line with a slope of 1 that intercepts at 3. So somewhere here at 3, I just have a line that goes through this thing like that. Right? Now I need to test, because it's an inequality, again, I need to test to see where I'm going to shade, either up or down. Right? So this really is just cut this parabolic little shading in two pieces. It's either this top little bit or it's down forever that way. Right? But again, I can test 0, 0 because I don't go through it. So I'm testing 0, 0 into the inequality. So 0 is greater than or equal to 0 plus 3, but that is 0 is greater than or equal to 3. That's false. So in relation to this line, the 0 is down here below it, the 0, 0, so I'm going to shade the opposite area because it's false, and so I shade this little enclosed space. And I know it's hard to see because these shading isn't the best on these markers, but it's this little shaded part right above here. Just ignore the rest of that junk. It's this right here. Right? All right. That answers 7. You would just have to find, there's like 800 pictures down below of, you know, this is dotted, that's dotted, you're shaded all over the place. Find the one that is the dotted parabola, upside down, up, shifted up, and then the solid straight line, and then this shaded area in here, right? And that's 7. Number 8 then, though, asks us about these two points right here and here. And it also asks us if it is, there's a drop down that says it's either bounded or unbounded. It's bounded because it's like it's enclosed inside a fence, right? So it's bounded. And then it asks us about these 2 points. These 2 points are vertices where one of the inequalities intersects with another inequality, right? And so I really want to find out where those 2 things happen. I can do it algebraically or I can do it graphically. It's hard graphically, especially with the junk that I've drawn here. I have no idea where my x values are. I don't know if this is -10 or -1 or -1,000 because I didn't take time to draw this very well, right? If you find this on the graph, you can count the little squares because it's done it much more nicely and neatly. But to do it algebraically, let's just take a look at what this means. Right? At this point here, the x and the y values have to be the same, right? Which is to say that this y value has to be the same as that y value, and this x value has to be the same as that x value. So I'm going to erase all of this because we're going to do this algebraically. All it really means is if this y value has to be the same as this y value, then this 9 minus x squared, which is on the border of this y value, has to be the same as the x plus 3, the border of the other y value. And you can see we'll simply get a second degree polynomial out of this, right? I'm just going to grab everything and bring it to the right by subtracting 9 and adding x squared to both sides. So I have 0 on the left. On the right hand side, I'm just going to write this in descending order as x squared plus x minus 6. But you can see this factors to x plus 3 and x minus 2. Right. Which gives us 2 values, which makes sense because there was 2 spots where our x values were the same. So this tells us that x is going to be equal to either a 2 or a -3. And then all I have to do is plug these back into one or the other, it doesn't matter, plug it into the boundary of this. So I'm going to plug it into y equals, say, x plus 3. I'm going to say x is 2, so that gives me 2 plus 3 is 5, giving me the point 2, 5. When I plugged in a 2 for x, I got a 5 for y, so that's 2, 5. And the other one I'm going to plug in a -3, so that's y equals -3 plus 3, but that's 0. So that gives me the point -3, 0. Okay. Good. Let's take a look at number 11 and 12. Which is very similar. Well, similar question, at least. We have a system here, x squared minus y is less than or equal to 2. and x squared plus y is less than 6. Okay? Now if it were me, I would change this just because I like the way it looks to have the y isolated on the left hand side. So the bottom one's easy, I can just subtract x squared over, so this is y, I keep the same sign as less than negative x squared plus 6. That one's easy. This one over here, to isolate your y, you would have to subtract your x squared, giving you minus y is less than or equal to negative x squared plus 2. But I want to get the y completely alone, so I'm going to divide everything by negative 1, which switches my inequality. Changes all of the signs, and it changes the direction of the inequality, right? So I have that. It's an equivalent system. And this is easier for me to picture in my mind, and therefore probably easier to graph. So let me get rid of this down here. Now if I graph this, these are both x squareds, right? This is an x squared, it's a positive x squared, so it's an upward facing parabola, but it's been shifted down by 2. And so down at 1, 2, it's just this. Right? It is indeed going to be a solid line because it's a greater than or equal to. So I do have this solid line, and then I just have to test a point to see where I'm going to shade. Okay? So if I plug in 0, 0, because I can, I get 0 is greater than or equal to 0 minus 2, but that's true. 0 is indeed greater than negative 2, so I'm going to shade lightly in the inside of that parabola. Okay. Now, this other one is an x squared, but it's negative, so that means it's been flipped down. But it's also been shifted up by 6, so up here at 6, I simply have a parabola going the other way. And it's dotted because it's a strict inequality. And then once again, I just have to plug in a point. 0, 0 is a great one because it doesn't go through it. So I've got 0 is less than 0 plus 6. And that's true as well. So I'm going to shade inside this parabola because 0, 0 is on the inside. And so that double shaded area is this kind of eggy looking shape right here. I don't know how well this is showing up. Hopefully not terrible. That looks alright, I guess. But it's this shape right here inside the two parabolas, right? And then you'll just again find that the graph of that down below. But they also again ask for the vertices. And that's these 2 points where those two intersect. Once again, you can do it graphically on the pictures in the homework because those are done with some level of accuracy. This is not, there's no way I could say, oh, I bet this is at 3. I don't know. It might be at 1,000 for all I know. So again, I'm going to come back here and do this algebraically. Right. Again, all I have to do is say, well, I can use the substitution. We're looking at the borders, so we're not interested in the inequalities anymore. We're looking at the border. All I have to do is treat this like a substitution and say, where is x squared minus 2 equal to negative x squared plus 6? So x squared minus 2 equals negative x squared plus 6. Okay? I always feel weird on this side of the camera because there's this weird shadow. Do a shadow puppet. Hello, I'm your math teacher. I'm on drugs. But all I have to do is then solve this, right? And that's my x values. So I'm going to take my x's to the left. I'll go plus x squared. But I'm going to also take this 2 to the right, so plus 2, plus 2. And so I've got 2x squared on the left. And 8 on the right. Divide each side by 2. That gives me x squared equals 4. But then, of course, this has two solutions. It's either positive or negative 2. So I have x equals -2 or +2. And then I just have to plug these into either one of these. It doesn't matter which one, you should get the same y values in either case. So I'll plug it into this top one because it's right there. If x equals -2, if x equals 2, but if it's -2 squared minus 2, but -2 squared is 4, minus 2 is 2. And I get the same thing here, 2 squared minus 2, because 2 squared is also 4, and so I get 2. So the y values are both 2. So I have 2 points. When x was -2, its y value was 2. And when x was +2, its y value was also 2. And those are my 2 vertices. And I'm good. All right. Hopefully that was helpful, and I will see you guys for the next one.